Okay, in this video, we are going to start Unit 3, which is Systems of Equations. So the first thing that I want to go over is the different types of systems that you could have. So the first one is parallel. Then there is perpendicular. Okay, then there is intersecting. And concurrent. Okay, so with each of these, there is different things that you want to look for. You want to look at the slope, and the y-intercept to be able to tell the difference between the two. So we're going to talk about the slope for each of them first. So the slope for parallel lines are going to be the same. So that's what makes them parallel, is that they're not going to cross because they have the same slope. And then for perpendicular, if you were able to do the extra credit section, you'll already be a little bit used to this, but the slope for perpendicular lines is going to be the opposite reciprocal. Which we'll talk about that in a minute. Then for intersecting systems, your slopes are going to be different, like completely different. They're not going to be this opposite reciprocal. And then for concurrent, they are going to be the same. And the difference between parallel and concurrent is concurrent means that it is only one line, meaning that you are given two different equations and they might be in different forms. So one could be in slope-intercept form and one could be in point-slope form. And then when you manipulate them, they end up being the exact same equation, which we'll go over a few examples of that in a minute. So that's the difference between parallel and concurrent. So now I want to go ahead and talk about the y-intercept for all of these. So your y-intercept for parallel lines is going to be different. So they will look the same going upwards, but they'll start at different spots. Then for perpendicular, they can either be the same or different. It doesn't really matter for perpendicular because your slope is going to be the opposite reciprocal. So that's what's going to make them different. Make them look different at least. Then intersecting is the same as perpendicular. So it can be the same or different. So if it's the same for either of those, that spot is then where they are going to cross, which is going to be your answer per se. And then for concurrent, your y-intercept is also going to be the same, again, because it is the same line. Okay. Now I want to go over the different types of systems that you could have. So there are three different types of systems. You could have consistent and independent, which means that you're going to have one answer, which means that the lines cross at one particular point. Then you could also have consistent and dependent, which means that they're infinite, which you have two equations but one line. And then inconsistent, which means that there's no solutions because they never are going to cross. So with that, parallel is inconsistent. So that means that there are no solutions. No solution, and lines do not cross. Okay. Then for perpendicular, these are consistent and independent. Sorry, kind of ran out of room. Which that again means that you are going to have one solution, and that is going to be a point, so it should be written like a point. And then your lines cross. And they're going to cross at that point. Okay, intersecting is the same, so it's consistent and independent. And then concurrent is consistent and dependent. So that means that there are infinite solutions and that's because it's the same line. Okay. So I want to show you some examples of these. Show you how to kind of tell the two or tell the difference between all of them. So if I give you the example of 2x plus 3y equals 4 and 4x plus 6y equals 9. So when you are given examples like this, you are going to want to get them always in the same form. So y equals mx plus b. So meaning that we need to get y all by itself. So I'm going to start by subtracting 2x on both sides. And then I'm going to divide everything by 3. And then I'm going to do the same thing over here. So I'm going to subtract the 4x. And divide by 6. Now, when I divide by 6, I need to make this as simple as possible. So 2 goes into both 4 and 6. So 2 goes into 4 2 times, and it goes into 6 3 times. And then 3 goes into both of these. So 3 goes into 9 3 times and into 6 twice. So as you can see here, my slopes are the same. But my y-intercepts are different. Which makes them parallel. Okay, so let's do another example with perpendicular. So there is x plus 2y equals 3 and 4x minus 2y equals 5. So I'm going to do the same thing over here that I did with parallel and just get them both into our y equals mx plus b form. Okay. Now with these, so if I look at my slopes, so they need to be opposite reciprocal, which means opposite meaning that you have opposite signs. So one is positive and one is negative. And then reciprocal meaning that if you were to flip your fraction around, it would look like your other number. So if I were to flip this upside down, it'd be 2 over 1, which is just 2, which is this right here. So these need to be opposite reciprocal. Cool. And then your slope or your y-intercept can be the same or different in this case. Most of the time they will be different like they are here, but it can be either one. Okay. So now let's do an intersecting. So 3x plus 4y equals -3, and x plus 2y equals -1. So just like the other two, I'm going to want to put them in the same form. So I'm going to start by subtracting 3x. And divide both sides by 4. I'm going to do the same thing over here, so I'm going to subtract x. And then divide by 2. Okay. So when I'm looking at my slopes, first I need to see if they are the same or if they're opposite reciprocal, and they're obviously not the same. And then they are both negative, so they're not opposite, meaning that they're not going to be opposite reciprocal. So meaning that they have to be different. And then same with your y-intercept, just like perpendicular, they can be the same or different. But again, most of the time, they're going to be different. And last but not least, concurrent. So 4x minus 6y equals 12, and -2x plus 3y equals -6. So just like all the other ones, I'm going to start by putting them in y equals mx plus b form. So I'm going to subtract 4x, that's -6y equals -4x plus 12, and divide by -6. So y equals, so the two negatives make a positive, and I need to make that in simplest form as possible. So 4 over 6, 2 goes into both of those, so 2 goes into 4 twice, and a 6 3 times. And then 12 divided by 6 is 2. Same thing over here, so I'm going to add 2x to both sides. And divide by 3. Okay, so as you can see here, I've got the same, sorry, I'm kind of like scrunching all my stuff together. The same slope and the same y-intercept, meaning I've got the exact same equation. Okay, making them concurrent. Okay, so last thing I want to do is just show you a picture of what these are going to look like. So for parallel, perpendicular, intersecting, okay, so for parallel, you're going to have the same slope, but different y-intercepts. So you're going to cross your y-axis at 2 different spots, but your line, your slope would be the same. So it's going to look something like this, where you're so, but even though you've got your arrows saying that your lines are going to go on forever, your lines do not cross. Okay, so for perpendicular, where your lines cross is going to make a -90-degree angle, which means that they're opposite reciprocal. 90 degrees. Now that's kind of hard to tell the difference between that and intersecting just by looking at the lines. So you'll want to at least figure out what the slope is of your two sets to tell the difference if it's perpendicular or intersecting. So for intersecting, excuse me. So you'll have something kind of like this, where they cross at just one point. And then concurrent, kind of being the most obvious, is just going to be one line. Okay. Okay, last thing that we need to do is just go over the vocab for the unit. And hopefully you guys don't hate me, but there's only one word. So And that word is system of equations. Surprise, surprise. So systems of equations are two or more. Now we will only be working with 2 in Algebra 1. You'll have 3 once you get to Algebra 2. So this will come back up. Or more equations that must be solved together to find the solution. And going on that, the solution to a system is an ordered pair, which is just another word for a point. So your x, y. That makes both parts of the system true. So that meaning, so when you get your point x and y, if you plug those back into either one of your equations, it will actually work. So say that your point is 1, 1. So if you plug in 1 for both x and y, your 1 will actually equal 1 on both sides when you plug in your point. And then you can have you can either have one solution so that is going to be your perpendicular and intersecting. And that's because you're going to cross at just one spot, making that your one solution. And that solution must be written as a point. So x, y. So when you write your answer, make sure that you put it in a point format. So you could also have 0 or what's called no solution. And that's going to happen with parallel. And that's because your lines don't cross, so you're not going to have a solution. And then also your infinite solutions. And that is going to be your concurrent. And that's because it's the same line. So all of your answers, it's going to work no matter what because it's the exact same line. It's not going to just work at the one spot like perpendicular and intersecting. Okay. So let me know if you have any questions. Otherwise, you can go ahead and get started on your first section. Thanks.